Hi and welcome to this short webinar offered by IAC Systems on the latest implementations made by Carel to the new air handling unit software designed in one tool. The purpose of this seminar is to highlight the new features of the software revision 1.3 and the many benefits that you can take with it. The core new improvement in this new software version is the compatibility with the new Pico 5 platform. The software has been designed to run on Pico XS, Pico 3, and now also on Pico 5. What does this bring with it? Well, first of all, from a hardware point of view, the Pico 5 makes it simpler to upgrade software thanks to the built-in USB port available on specific models. You can see the USB in the center position of the controller. The USB connections come with a master and a slave port. The one used to connect a traditional USB pen. This is to allow a quick and easy air handling unit software upgrade. You can store more versions on a USB pen and decide which one to use, or alternatively, download log files from the controller. The second USB port instead is used for a point-to-point connection to a laptop or personal computer via a USB cable. Please note that this will allow a simple connection from a PC to a controller without the need for a converter. This port is useful for a software update of or log downloads, as well as for commissioning purposes. Thanks to the Pico Manager software, downloadable free of charge from the Carel KSA website, it is extremely easy to commission and configure an air handling unit or record live data from the controller, such as temperatures, device conditions, alarms, etc., during a running operation of the unit. What I want to talk to you about now is some new hardware features that characterize the Pico 5, because they are at the root of the enhancements of many features of this new software version 1.3. The Pico 3 had 3 serial connections, of which 2 are optional plug-in modules. The Pico 5 instead has much more of a greater connectivity with 2 embedded RS485 serial ports, 1 for field device connections such as inverters, temperature and humidity Modbus sensors. In the near future, Modbus EC fans of Zeal and IBM Pabst will also be integrated in this serial link. The second embedded serial port is a Modbus slave for a remote connection to either a BMS on Modbus protocol or alternatively for a connection to the new PGD touch display launched recently by Carel. The same 2 optional plug-in serial connections of the Pico 3 are also present on the Pico 5. The first one is available for an integration with the Belimo MP bus actuator. This can control up to 8 actuators on this serial link. The second optional serial line is for a BMS integration. This port hosts plug-in cards with BACnet over IP and BACnet over MSTP, SNMP protocol, XML and email facilities on the web server of the Ethernet interface card, Modbus over IP and Modbus over RS485, LON and Connex protocol. It is important, I think, to explain the concept that lies behind this software. The idea was to design one software that can suit the vast majority of the air handling unit configurations that are out there on the market, no matter how complex they may be. The challenge has been to make a software suitable for every need, yet very energy performant, simple to use, and mostly very intuitive. After a few years of study and development, the results have been pretty amazing. Let me try to illustrate them to you. I like comparing the infrastructure to the Lego bricks. What do I mean? Well, with a few Lego blocks, with its many and different shapes, you can build nearly anything, and mostly with some quite robust infrastructure as well. This software is comparable to a box full of Lego bricks, with which you can have the pieces to build the most robust and effective air handling unit control strategy, without having to be an expert software developer of ladder logic. You only have to pick the control modules that apply to your air handling unit from the manufacturer menu and simply activate them. Once these modules are enabled, they will automatically link among them, giving shape to the best practice controls philosophy and offer accurate and comfort temperature, humidity and airflow control. The blocks I'm talking about are dampers, fans, coils, safeties, humidifier, filters, heat recovery, and many more. Let's take a look now at what are the benefits of such a controls vision for these type of applications. You can entirely eliminate all the costs related to software controls modifications that may be required in every different job. This eliminates any customization you will require, also to manuals and documentation. Here you have a one solution will fit them all. This is no little importance if you consider that every customization adds a high risk of human errors in software bugs, which can easily translate into expensive and embarrassing problems to fix, especially once the unit are on a running building and which is under its warranty period. Carel's strategy is to make business on controls equipment, on hardware. This software is offered free of charge for now. Maybe one day things may change. This means that you can benefit of all the new enhancements that will be part of future software releases without spending a penny. For example, one item that is in the pipeline is the Modbus integration of Zeal and EBM-PAPST fans. This is quite a self-explanatory statement. You will be able to reduce the engineering and commissioning time by getting rid of a personal computer. The software is already compiled and engineered by Carel. You reduce amount of different controls models to be kept in stock. The scalable platform allows you to use one control model for the many different protocols required. Just change the plugin card according to the specific integration on site. As a direct result, you will get a smaller controller for the same control point. This is thanks to the higher field connectivity. Many of the points are no longer physically connected to the inputs and outputs of the controller, but are connected via serial link. The cost reduction we refer to here is related to the fact that you no longer need an LCD display for each inverter, and if you are used to remotely export the display on the outside of the air handling unit in a box, your kit becomes even more expensive. You will see all the inverter parameters on the main air handling unit LCD display. One display, one menu navigation style. Of course, not to mention the cost savings in less wirings and also the better monitored inverter. This increases the profile of your control system to the end user. The average percentage of wiring reduction around the air handling unit is about 70%. This is applicable when you may want to opt for a Belimo MP bus integration of the actuators on the unit. Allow me to comment that the configuration of the MP bus network is as simple as drinking a glass of water. We have spoken about the scalability before. This control solution is standard and suitable for the simplest air handling unit up to the most complex. Inputs and outputs. The Pico 5 control platform comes in three sizes: the small, with about 25 physical control points, 5 sensors, 4 analog outputs for dampers and valves actuators, the medium, with about 40 control points, the large, with 52 physical control points for each air handling unit. Should this not be enough, the software is capable of integrating with up to a maximum of 2 expansion boards, where each can accommodate 13 additional points. If you sum these up, you get a maximum configuration of 78 control points, without counting the virtual points on Modbus field connection and the MP bus serial connection. Amazing for a standard application. So this is how the topology of the controls will look like. The controller connects to physical points summarized in the previous slides. The first serial line is for a Pico local area network used to connect local displays, also called PLAN. The second is the embedded Modbus serial line for inverters and sensors integration. The third is the optional MP bus card for Belimo actuators integration. The fourth is the embedded MP BMS Modbus slave port for a remote connection to either a BMS on Modbus protocol or to a PGD touch display. The fifth and last serial port is the optional BMS port that will allow a remote connection to any BMS system using open protocols. The available protocols are Modbus over IP and RS485, BACnet over IP and MSDP, LON, Connex, SNMP, email facilities and HTTP protocol. The IP card has an embedded web server with 8 megabytes of memory. It's a software translated in more languages. On version 1.3 there are new languages now available. The application has been translated in English, Italian, Spanish and German. The software has a memory allocation to back up the configuration you had made on the controller, so if accidentally the configuration may be changed and the controls condition have degenerated, you can easily restore the original configuration from the last backup restore point. A new water temperature sensor has been added so to establish the conditions to automatically change over the operation mode from summer to winter or vice versa, depending on the temperature of the water flow. This temperature sensor can also be used to prevent the valve to open if the water temperature has not reached a minimum temperature threshold in both heating and cooling mode. This feature is available for all water coils of the air handling unit. On this software version 1.3, you have the possibility to set a minimum opening position in percentage for each water coil in the following conditions. On unit on, this is quite handy in large air handling units with small coils, where a water valve opened at 2 or 3% would bring no temperature increase or decrease, depending if this is cooling or heating coil, thus wasting energy. On unit off, this is a feature used in Nordic countries. In anti-block safety modes, on the previous software version, Carel had introduced the management of a single or twin pump sets for each water coil. In the management module, the user has the facility to enable an anti-block function where on every 7 days of inactivity, the pump will be enabled to run for 30 seconds. In the software version 1.3, this operation has been extended also to the water valve. This is also called a valve exercise. Nice new little feature is the fan conversion flow rate module. By applying the conversion factor found on every datasheet of the fans, the software will automatically convert the pressure into airflow in cube meters per hour. All set points will also be converted into this unit of measurement. There are also a few more controlled variables, quite useful, I must say. You have a new cooling off-coil humidity probe. This is to allow, on top of the already available dehumidification dew point control probe right off the cooling coil, the possibility to control dehumidification on a humidity set point. The newly added temperature probe positioned after the heat recovery will measure the efficiency of the heat recovery, converting these calculations into its proper unit of measurement. A new digital input for fire alarm override button has also been added. The air handling unit will keep off the supply fan, keep the fresh air damper shut, and open the expulsion air to finally switch on also the extract fan. The cooling step control has been enhanced with a fourth stage of cooling. Last of all is a handy minor alarm indication which has no impact on the control's effect on the automatic regulation of the air handling unit, but will simply pop up a screen on the display warning of the alarm being activated. This can be handy for remote condensers alarms, for example. Now, this is the cherry on the cake. In many new air handling unit installations where cooling is a big part of the energy consumption, like in data centers, for example, the evaporative cooling technology has been largely explored, for it provides considerable amount of savings in energy usage. Carel is the leading manufacturer in Europe for humidifiers and has integrated this technology in the air handling unit software in this version 1.3. The control strategy allows for the management of a direct evaporative cooling which sprays water straight into the supply flow by making sure that the supply conditions are well within the permissible limits, and manages the indirect evaporative cooling, which instead sprays water on the return airflow. The air handling unit software controls these cooling devices by enabling them to operate if the system is within working limits and if there are enthalpic conditions, and will run them in sequence depending on the cooling demand, from the most efficient to the least efficient. For every liter of water being sprayed, you get 690 watts of cooling, and on average, you can achieve a temperature reduction of about 10 to 12 degrees Celsius between return and supply air. The energy savings of this system is unbelievable. With 100 kilograms of water, you get nearly 70 kilowatts of cooling with a current consumption of little less than a kilowatt. While with 600 kilograms of water, you achieve 414 kilowatts of cooling with just 1.95 kilowatt of absorbed power. Well, for now, this is all. Stay tuned for more updates. And I suggest you to register to our newsletter so to be automatically updated on news, events, webinars, and more tutorials. Visit our website for more information on the air handling unit products on www.i-acs.co.uk. Thank you.